Good morning, everybody. Welcome, student. Department of Computer Engineering and Information Technology. Again, I am telling the subject is same. The for this computer engineering and the information technology of CO3I and IF3I also. The subject CO3I for DMS 22318 and IF3I for POD 22321. In previous video, we learnt about what is data, what is database, overall structure of the database, as well as data modelings and so on. I hope all of you understand about this chapter, regarding this chapter. Then, if you have any doubt, you can put the message on the WhatsApp. Learning outcome of this video: fundamental of RDMS. RDMS, the relational database management system. The basic concepts in the RDMS is record, tuple, field and data types also. Then, rule of RDMS and normalizations. I will try and cover all the topics in the learning outcome, but if any doubts or any types of the topics are remaining, I will explain in the next video. So, the chapter 1, relational data model. This chapter is given for the 18 marks, is for CO3I. But relational models topics in also POD subjects for this IF3I. Then the relational model. Now we will going through the step by step in this topic. Then, a relational database is a collectively combinations of the data structure, storage and the retrieval operations and the integrity constraints. It stores data in the form of tables. This concept is introduced by Dr. A.F. Coors, a researcher of IBM. It is most famous because of its simplest structure as compared to other databases, like a network or the hierarchical models. The network model, hierarchical models we learned in the previous lectures. The set of relations and the set of domains that defines the way data can be written. Now, characteristics of relational database. Characteristics of relational database. The first is, each relations in a database must have a distinct or a unique name which would separate it from the other relations in a database. A relation must not have true attributes with the same name. Each attribute must have a distinct name. Third, duplicate tuples must not be present in a relation. Fourth, each tuple must have exactly one data value for an attribute. Fifth, all values entered in the columns are of the same data format. Sixth, a table is also formed in the two-dimensional structure. Number 7. column represents the attribute and each column has a distinct name. In these characteristics of relational database, the two basic concepts of relational DBMS. First is table, second tuple, it's called as the record, third attribute, it's called as the field, fourth database, fifth is the domain. First is the table. Everyone knows about the table. Tables, it is a combinations of rows and columns where records are represented by rows and attributes are represented by columns. It is the important things about the tables because the records are represented by rows and the attributes are represented by columns. Then next is the tuple, it means record. Tuples is a single row of the table. It contains a whole record of a particular data items. It's called as the tuple. Then third is the attributes. It's known as the field. It is a column of a table. Attributes are also known as the fields. Students understand this topic because it is the concept of a relational database. Everyone knows about the table, what is table, record, attributes, and database. Then tables, you know very well, but it is the in a single way. It is a combinations of rows and columns. But single row is the of the tables is called as the tuple, and column of the tables is called as the attributes. Then fourth is the database. Next is the data types in SQL. SQL structure query language, and in this language data types are also used. Then there are the 10 data types are used in the SQL. The first is here shown the list of the data types in SQL, and another briefly explanation in detail explanation in the next slide. The first is the character, char, in bracket length. Second, var in bracket length. Third data type is the boolean. Fourth data type is the small integer, and fifth is the integer or INT. 6 is the decimal, 7 is the numeric. First is char. The char data type accepts the characters or string type of data, including the Unicode. It is known as the fixed length data type. For example, char in bracket 20 is the size of the character in bracket, or character whole spelling of the character, then in bracket 20. Then the phonics, comma, and the infotech, giving the example of the character length. Up to 20, you can use alphabets. Then second is the varchar length. The char data type accepts the character or string type of data, including Unicode, and it is the known as the fixed length data type. For example, varchar in bracket 10. Then phonics and the infotics are given the example of a varchar element. Third is the Boolean. The Boolean small int entity. The small int data type is used to accept the numeric values with default scale at 0. Next is the fifth, integer or int. The integer data type is used to accept the numeric values with a default scale at 0. 6. Decimal. The decimal data types is used to accept the floating point value for which you defined a precision and a scale in the data types declaration. Example, decimal in bracket 10, size of the 10, 3 bracket complete. Then seventh, numeric. It is the same as of decimal. 8. Float. The float data type accept the approved. Now, next step, the Dr. AF code rules for the RDBMS. The code designed these rules to define what is required for the relational database management. All these 13 rules are followed by very few commercial products. Even the Oracle followed the 8.5 rules out of the 13. So, the code's rule 0, is the foundation rule. Foundation rules states that the system must be capable to manage their database system through their relational capabilities. All other 12 rules are derived from its foundation rule. Rule number 1. For any system that is advertised as a claim to be a relational database management system, that system must be able to manage the database entirely through its relational capability. Rule number 1. The information representation. The information rule. All the informations in the database must be stored in the standard form of tables. And table is considered as the best format to store and manage the data. All informations in a relational database is represented explicitly at the logical level and in exactly one way by values in the tables. Rule 2. The systematic treatment of a null value. Null values, character strings or string of a blank characters and the distinct form 0 or any other numbers are supported in fully relational DBMS for the representing missing the information and inapplicable informations in a systematic way, independent of data type. In a database, the null values must be given a systematic and uniform treatment. In number of cases, we may have to set null values on place of data. For example, data is missing, data is not known, or the data is not applicable. Null values is different from the empty characters or string of a blank character, and it is also different from the 0 value or any number. For example, in the employee tables are there, that time employee ID is given for the every employee, name is also of the employee, and department, some testing department or some null department, because the phone number and everyone's have phone number. Is it right or wrong? I don't know, but some peoples are not having the phone, so that's why the null value is there. And rule number 3, the guaranteed access rule. Each and every autonomic value in a relational database is guaranteed to be a logically accessible for restoring to combinations of a table name, primary key value, and a column name. In a database, every single data element must be accessible logically with the combinations of table name, primary key, and the attribute name. There should not be requirement of any other entity to access the data. Then, next thing, rule number 4 is the active online catalog. The descriptions of the structure of the entire database must be stored in an online catalog known as the data dictionary. And the data dictionary can be accessed by authorized users. Metadata should be maintained for all the data in the database. The system must support an online, inline, relational catalog that is accessible to authorized users by means of their regular query languages. That is nothing but just like a ordinary data. The database descriptions is represented at the logical level so that it's possible for authorized user to apply the same language of the regular data to its interrogations. Then rule number 5 is the comprehensive data sublanguage rule. The database should not be directly accessible. It should always be accessible by using some strong query languages. This rule illustrates that the system should support at least one relational language. The language has a linear syntax, can be used both interactively and within an application program. And suppose the data definition operation, including the view definition, data manipulation operation. In this data manipulation, the update and retrievals are there, the security and integrity constraint, and the transaction management operation. Rule number 6 is the view updating rule. Views are the virtual tables created using the queries to show the partial or complete of the table. All views that are theoretically updatable must also be updatable by the system. The rule stated that we should be able to make changes in a view. Rule number 7 is the high level ASA update and delete rule. High level means multiple rows from the multiple columns are affected by the single query. These rules states that a database must support insertion, updation, and deletion. This must not be limited for a single rule. That is, it must also support union, minus, and intersection operations to a set of data records. Suppose, for example, employees got a 5% hike in a year. Then their salary has to be updated to reflect the new salary. And since this is the annual hike given to the employees, this increment is applicable for all the employees. And hence, the query should not be written for updating the salary one by one for thousands of employees. So, A single query should be strong enough to update the entire employee's salary at a time. And after that, the whole entire employee's salary changes from that day. Then, rule 8, the physical data independence. Changes in the physical level, format of a data storage or the container of data like array or the linked list must not require any change to an application. Rule number 9, the logical data